Good evening, guys. Today I will talk about the simple pendulum, how we can use it according to our purpose to calculate the acceleration of free fall ball, what I mean, and some important information about it. Actually, from the purpose, it's very important because from the purpose, you should know your main goal. You can solve any question because any question will come from this purpose, depending on this purpose, because it's our main goal. According to the purpose, to determine the acceleration of free fall ball, and this is the simple pendulum. We have a pendulum, this mass, this iron mass, doesn't matter, it's equal what? The string, this is the string, but the most important thing is should the difference between these two masses, I mean the iron mass and the string mass, should be huge to give us opportunity to ignore the string mass, the stand, the clamp, and the meter scale. What I mean by saying a free fall ball, I mean this mass is connected from a specific point from the top, and here it can freely moving from any point if we apply a force on it. Okay, here this point is the equilibrium point. It's according to just the gravitational force. It's from top to the bottom according to just gravitational force. Free fall ball, that's mean freely moving from point to point according to this degree, this angle, simple angle. I will say it and see it in the next slide. Throwing from the equilibrium point like that. Here, a simple pendulum consists of mass, the iron mass, hanging from a string like that, from a specific point. It's a pivot. We can say it's P. The length of the string is L. We will change the length of the string. When displaced to an initial angle is approximately 10 degrees and release, that means take this mass from the periodic, from the equilibrium point to this point and release it, will go and come back to the same point, no more, and will be some less because it's acting with two forces. First one, the gravitational, or let me say, start from the fractional force, air fractional force. Second one is the gravitational force, okay? The pendulum will swing back and forth with periodic motion. What is the oscillation? The oscillation, it's the distance from this point to this point. When displace the pendulum from the equilibrium point by using simple angle, not more 10 or 15 degrees, and release it, will go and back to one complete time. It's named oscillation. What is the time period? The time period is the necessary time to this mass, this iron mass, will have it when go and back to the same point. It's the time period. Before talking about the frequency, we will apply important thing. This is the accuracy. Accuracy, it's depending on standard results. Standard results. To minimize our mistakes as can as possible, here our standard result is the acceleration result. It's 10 9.8 meter divided on second square. Okay, our goal to reach number near from this standard acceleration result. That's according to the accuracy. What about the precision? Precision, it's to minimize the mistakes as can as possible. That's right, but uh, by do the same duty to many times. Okay, let me explain how and how we will do that. The frequency, that if the frequency equal 10, that's mean I will take 10 oscillations. I will calculate the time to 10 oscillations, and after that divide it on 10 to can take better results. That's according to the precision. We'll do that 2 times and take the average to divide it to 10 to can reach the time to one oscillation. I will explain that all that in next slides by using a column. The frequency is the oscillation is the number, the oscillations, frequency of the oscillations is the number of oscillations that occur per unit time, and it's inverse with the period. Method will start from, we'll use length, string length to be 100 centimeters. Place a piece of paper here to to be sure that this mass will moving freely. We will depend on 10 degrees. We'll take time average. We will shorten this length or increase the length of the string. Doesn't matter, the same. We will work on 10 oscillations. Other professors works on 20 or 15, doesn't matter. Here, it's the important table here. The first one, the length of the string, for example, 20, 40, 60, 80, 100. I will take the time to 10 oscillations to apply the precision, and I will do that again. Should all of these two results be near from each other, divided on 2 to take the average to 10 oscillations, divided on 10 to can calculate the time to one period. Why? Because to plot my curve, just I need L at x-axis and the time square to one oscillation to each length at y-axis. Okay, all of these to apply the precision. Here, the relation between them should be linear direct relation. Here, it's a simple pendulum because the angle is small. By that, we can say it's simple harmonic motion. When theta is so small, we can say sine theta equal theta, approximately. Here, it's important to say by the accuracy, the result of the acceleration, and we will depend on this number to can reach the nearest number of it. Newton's second law say any force, it's equal the mass and the acceleration to equal this force. But when we talk about the gravitational force, here the acceleration should be not with a simple, should be with g, okay? Because we are talking about the Earth's gravity. It's necessary to say from where we have this formula. The acceleration according to the gravitational force equal 4 pi squared divided on slope. From where I have it? From the angular frequency. When angular frequency square equal acceleration divided on L. Let me multiply it. Let me say the angular frequency equal acceleration divided on L to root 2. And let's write another formula of angular frequency by using the frequency element. to be angular frequency equal 2 pi f. When frequency equal inverse the time, that means angular frequency equal 2 pi multiple 1 divided on t. It's equation number 2. All of these 1 and 2 with the same angular frequency, because that we can say 2 pi multiple 1 divided on t equal g divided on L to root 2. Let's multiply this result to, at first, let's calculate the t from these two equations to be t equal 2 pi multiple L divided on g to root 2. Let's multiply this formula to be t squared equal 4 pi square multiple L divided on g, acceleration. Now let's calculate the t square from tan theta, from slope. When slope equal delta t square divided on L, that means t square equal slope multiply L. All of these two formula, two equations to the same t square. By that, by cancel all of these L from these two sides, slope will equal 4 pi square divided on g, and we can say g, the acceleration according to the gravitational force, will 4 pi divided on slope. By that, it's necessary to calculate the slope to can determine our purpose, the acceleration. Here, determine the acceleration of free fall ball by using simple pendulum according to the column below to 10 oscillations. The frequency is 10. Here, number 1, 20. I calculated the time. I did that again. Average. Here it was the average to 10 times. Here divided on 10. Here I have the t square. It's equal dot 789. It's no way to can upload number like that at x or y, because that let's say that it's equal approximate dot 8, approximately equal 1 dot half. Okay, the same formulas, the same equations to prove the acceleration equal 4 pi square divided on slope. Here, our relation here, it's linear, direct. That's mean our working is right. Here, just we have this number. This point is a regular point because that is outside of this oblique line. Let's calculate. Here we have many numbers. We can calculate the slope from it. And after that, g equal 4 pi square divided on slope. You should calculate the best number of these many slopes to can reach the nearest acceleration from the standard result from 9.8 meter divided on second square. Okay, here it's equal y. You should think about it. Here with centimeter divided on second square, not meter divided on second square. That means it's a great calculation to us. It's equal 9.859 meter divided on second square. It's very near from the standard results. What about the conclusion? The relation between them is linear. Here, the slope is positive. That means it's direct relationship, linear relationship. This point was irregular points outside the oblique line. That's it. See you in next video. Let me